Okay, so in this video, we will go over confidence intervals. Alright, so usually in statistics, when we're trying to give an estimate of a probability, if we're trying to estimate a probability, usually the case is we're not gonna give the answer in a single form number. Chances are the probability will be around the average or the expected value, but it's not gonna land on the right on the dot. And that's where confidence intervals becomes useful, because what confidence intervals are is they'll give a range around the mean where we base our prediction around the mean, but also based off how confident we want to be, as well as the standard deviation and the sample size. All right, so right here is a given formula for finding the standard deviation. Looking at it right away, it doesn't look the most useful. I'll go over each variable by variable to interpret what this confidence interval actually means. But we learned about the mu. The reason why we have our plus or minus as well as our alpha divided by 2 is simply put, if we draw the normal distribution again, when we give our confidence interval, the result we get can be obviously less or greater than the mean. So let's say our confidence interval is around here, and we want our confidence interval to be exactly, whether no matter what, we want it to be the same standard deviation, less or more. So let's say our confidence interval ranges around here. Because both the two tails, one in the left and one in the right, are empty, we have two spaces within the normal distribution where that falls out of the confidence interval. So that's why we're mostly, we have to, when we're calculating the CI, we have to calculate both sides of the tail. Again, this will become more clear once we actually do some of the examples, but just wanted to give a further explanation on why there's a plus and minus and then the alpha divided by 2. N minus 1, again, that's mostly for the degrees of freedom, but the n is important because our sample size plays a huge role in calculating our not only the confidence interval but our z-score first. So this part of the equation right here it's usually going to be given to. We don't sometimes, problems on tests or practice problems, they'll try to trick you by saying, oh, what is the CI given, like alpha equals this, and then you sometimes students forget to divide it by 2, but usually this part will be given as a z-score. So if the problem asks calculate the 90% confidence interval, then that will mean we substitute this part right here into a 1.695 or 45. I'm sorry. Let me just rewrite that. The most common confidence interval we usually use, at least in my experience, is the 95% confidence interval, 1.96 z-score, and then 99% confidence interval we'll use a fairly high z-score number. And so notice how the more confident we want to be, the bigger the z-score becomes, because generally the bigger the z-score, the bigger our overall confidence range will be. And that intuitively that makes sense, because the bigger our the more confident we want to be. If we want to be 99% confident opposed to 90% confident, we want to give the answer in a bigger range, so that we make sure that the probability of the random variable falls within the given interval. And increasing that interval helps the chances of the random variable falling within that interval. All right, and then as for the last part of the equation, that's the standard deviation divided by the square root of the sample size. So this is what we call the standard error, short for SE. And it is similar to this standard SD, but we're basing off the sample size. So notice how if the I'm not going to write it down right now, but notice how if the standard deviation increases, then our confidence interval will also increase. Again, if our standard deviation is higher and there's more variability within the data, then our confidence interval it makes sense that it will become bigger, because there's a bigger spread generally towards the data. And so a lot of if the SD is bigger, then a lot of the data points in our data set are not around the mean. And then for the sample size, again, our sample size, recall the central limit theorem. As sample size increases, the normal distribution will become, or the distribution will become closer to a normal distribution. So generally just speaking, as the sample size increases, our reports on our confidence interval becomes more accurate. And that's why it's in the denominator, so that if the sample size increases, the confidence interval actually decreases. Likewise, if we have a small sample size, then we're going to have to give a large confidence interval, because we can't utilize, we can only utilize so much an unreliable amount of data that we have. If the sample size, it's less than 30 or whatnot. Okay, so let's get to a couple examples. So let's say we're given that the average of a data is 30, the SD is 10, and then the sample size is 100, and then we're assigned to give a 90% confidence interval. So using the formula up above, we will write 30 plus or minus, and then this part right here, again, that's if we're given the sample size, we're given the sample size, but if we're given like alpha, then simply just divide it by 2. But if we're given the z-score, then, by the way, the alpha, again, it represents kind of this area right here, and so that's why we're dividing by 2, and then we're also plus or minusing it to compensate for the to consider both sides of the interval. Okay, so we're giving that we have to find a 90% confidence interval, so 1.645, and then we're giving a standard deviation of 10, and then sample size of 100, which we have to square root. So this part right here comes out to be 1. So it's just 30 plus or minus 1.645. So that interval will be 28.355. Minimum being the 28.355 to 31.645. Okay, so that will be That is our 90% confidence interval given these statistics. And then, so I guess just looking at it, it doesn't seem like a far off range, which makes sense because we have a large sample size. Our standard deviation isn't that large. I guess there's nothing else to grade it, base it off. But let's do the second example where, again, just to interpret this again, we're 90% confident that we're 90% confident that given these statistics, a random variable will fall within this interval range, 28.355 being the lowest and 31.645 being the highest. Okay, so if we want to be more confident about our random variable falling in a given interval, let's say we want to be 95% confident. So it will be a similar formula, except we would use a different z-score. So in this case, 1.96. Again, this turns out to be 1, and then our confidence interval results in 28.04, 31.96. So if we compare these two intervals, right, the 95% confidence interval actually turns out to be a bigger range meaning subtracting from the higher to the lower one. And this, again, intuitively, this makes sense because the more confident we want to be, the more confident we want to be, our confidence interval increases. And I won't do, this will just be the two examples I'll do, but just looking at the formula given here, right, we can kind of see that as the standard error or the standard deviation increases, the CI will also increase because we have to compensate for the higher variability within our data. The mean doesn't mean much if the standard deviation gets higher. And then finally, as the sample size increases, our data becomes more reliable, meaning that our mu becomes more our mu gives a better representation, and our standard deviation is not as affected. I guess that's the way to put it. I wouldn't say that. It's just simple. It's just a sample size. All of our other metrics become more reliable when our sample size increases. So as n increases, the confidence interval decreases. Okay, so that will be it for confidence intervals. I think in the next video, I'm probably gonna kind of go over the summary, not all of what I did so far, but just some of the useful statistics that I did. And I won't do it on this Blackboard. I want to kind of demonstrate it on a software. So I'll be doing that in the next video.